Hi students, this is Dr. Senthil Selvi, Professor Department of CSC from SRM Institute of Science and Technology, Ramapuram. Today we are going to discuss about fog computing communication technologies. Basically, fog computing communication technologies divided into wireless communication and wired communication. So it is used to communicate between the IoT, that is front-end devices, as well as between the edge devices and cloud server. This is a communication between cloud to fog, fog to front-end devices, between the front-end devices, between the fog nodes. It is basically categorized into two categories: wireless communication and wired communication. We will see one by one. First one is wireless communication technologies. Under wireless communication technologies, the first one is Wi-Fi. It is IEEE 802.11. It is used for local area network connectivity, and Wi-Fi is suitable for the connecting devices within a limited range, such as smart homes, offices, and industrial settings. Next one is the Bluetooth one. So it is IEEE standard is 802.15.1. It is used for short range communication between the devices. It is often used in the IoT applications like wearable devices and smart sensors. Next one is Zigbee. The IEEE standard for this one is 802.15.4. It is a low power and low data rate wireless communication protocol. It is used in home automation and industrial control and sensor networks. Next, we are going to discuss about that is a long range, low power wide area network. First one is long range wide area network. Another one is low power wide area network. That is suitable for connecting IoT devices over a large areas, such as between the cities and agriculture monitoring systems. Next one is 5G networking. This is the fifth generation network technology. It provides a high speed and low latency communication. It is for computing applications like autonomous vehicles, augmented reality, and real-time analysis. So, under wireless communication technologies, we have discussed Wi-Fi, Bluetooth, Zigbee, low range power low range wide area network and low power wide area network. Next one is 5G network. Next, we are moving to wired communication. Under wired communication, the first one is Ethernet. For this one, IEEE standard is 802.3. It is a widely used communication technology for a local area network. It provides high speed and also the reliable connectivity between the fog nodes. Mostly, this is used by industrial and enterprise environments. Next wired technology is fiber optic. The fiber optic technique offer high bandwidth and low latency. It is suitable for the network connected with the fog nodes to the cloud data centers. The network connecting fog node to the cloud data center. Next one is fog to yes. Next one is edge to cloud communication protocol. It means that the edge devices, that is front end devices, smart devices to the cloud's data center. For this one, there are different type of protocols where we use the first one, MQTT, message queuing telemetry transport protocol. It is a lightweight protocol. It will publish subscribe based messaging protocol designed for low bandwidth, low latency networks. It is widely used in IoT and fog computing for efficient data exchange. Next one is constrained application protocol. It is a specialized web transfer protocol. It is designed for constrained devices. It is for IoT and fog computing application. It's requiring low overhead. Next one is HTTP protocol. It is a standard web protocol for communication between the fog node and cloud services. It is useful for RESTful application interfaces. Next one is AMQP QP, that is Advanced Message Queuing Protocol. This protocols support reliable communication between fog node and cloud services. It is used for enterprise applications. So far we discussed wireless communication technology, wired communication technology, and the edge to cloud communication protocol, that is front end to cloud data center. Next one is the communication between the fog to fog nodes. Here the peer-to-peer network enable the direct communication between the fog nodes without it depending on the centralized cloud data server. This communication will improve the scalability, and it reduce the latency, because every time we no need to communicate with the centralized cloud servers. It's communicated between them, the fog nodes. Next one is the distributed data processing framework, like Apache Kafka and Apache Flink type of this facilitate the real-time data streaming and processing across multiple fog nodes. It is for distributed data processing. Next one is a software defined networking. So it allows a dynamic management network resources. It enabling the routing and load balancing in the fog computing environment. It optimize the communication between the fog nodes and the cloud services. It solve the networking challenges while deploying the for federated edge environment. Next one is time sensitive networking. So it is IEEE standard. It provide deterministic communication with low latency and high reliability. It is suitable for industrial fog computing applications like automations and control systems. Next one is satellite communication. So here in remote and rural areas, the traditional communications infrastructure is not available. So that time we move to the satellite communication. That communication connect fog nodes to the cloud and other fog nodes. Next one is hybrid communication model. So here the fog computing often support the hybrid communication model that combine the wired communication, wireless communication, edge to cloud communication protocol, and fog to fog communication protocol. So the application of fog computing communication technologies where it is used in smart cities, industrial IoT and healthcare, and autonomous vehicle and augmented reality. This is about the communication technologies available in the fog computing. So we know the fog, what is fog computing? It is available under the cloud data center. So this is the reference I have used to prepare this content. Thank you, student, for listening my classes. Thank you.